Today we'll be looking at bearing and distances, and bearing talks about measuring location using the angles, and distances talks about the difference between 2 points. Now we'll be looking at a simple example. The thing is, bearing deals with cardinal points, so it is necessary for us to know our cardinal point. A cardinal point is like this, and here you have your North Pole, and here you have the West Pole, and here you have the East and the South. So this is what we refer to as cardinal point. And in bearing measurements, angles are measured from the north. So the north is usually at 0 degree. If we measure the angle from the north down to the east here, it's going to be 90 degree. So on our east you have 90 degree, and if you take it from the east down to the south, you have another 90 degrees. So from the north down to the south this way would be 180 degree. So we'll have here to be 180 degree. Now if you take it from the north down to the west, you'll be having 270, and if you take it from the north down back to the north, you'll be having 360. That's going to be a cycle, more like. We can see that if you have it this way, it comes back to the same point. It's forming a cycle, and we know that angle on the cycle is 360 degree. So these are some things that we should take very key note of. And the next thing here is that we should be able to identify where we regard to as our due west. For instance, a question directs a particular location to be due west. So this is what we mean. An example here says Aguda is located 600 meters due west of Lagos. Now if we're going to solve this, this is what we do. Now if this were my Lagos, which I'm just representing here as a point, so I have Lagos, this is the north. This cardinal point refers to Lagos. Then the question says Aguda is 600 meter due west of Lagos. So here Aguda would be 600 meter due west of Lagos, will be in this way. This is due west because this is tending towards the west. So you can use this diagram to show the distance that says it's 600 meter. So we can just leave this way here, and this becomes Aguda, and Aguda again will be represented in a cardinal point here this way. That is Aguda. So here I have my points, and I'll call it Aguda. So you can see here that Aguda is directly due west, so it's on the west direction of Lagos, and this is 600 meter. That's the distance between Aguda and Lagos. So this is what we do each time we're representing our points on a bearing. You take notes whenever anything is measured due east, due south, due west, or due north. It simply means it's directly on the direction of the north or east or south, as the case may be. Now we'll take another example here. This question says Benin is 80 kilometers due south of Kogi. Draw the bearing diagram. Let's see. Due south of Kogi. So we're looking at Kogi first. Let's say this is Kogi, and we have our cardinal point this way. So this point represents Kogi, and this is the north pole of Kogi. It said Benin is due south, so we're taking the direction of Benin down this way. Since it is due south, it's going to be along this path. So this is Benin, and we'll represent Benin also with the cardinal points, which is this point here, and this is the north of Benin. We'll just take it here this way. So Benin is due south. which means Benin is coming down towards the south direction of Kogi, and the distance between them is 80 kilometers. So this is what they talked about when they said due south, due north, and all that. Now I'll take this off, and we'll look at one other important thing in bearing. For instance, they said northeast. Let's look at this one. It's called, okay, let me indicate it first this way. North, east, south, and west. Now we may want to have a further direction like northwest, southwest, as the case may be. So I'll just indicate here quickly. This is my northwest, and this is my northeast. This is my southeast, and this is my southwest. Now the reason why it's called northwest is because the angle is taken from the north towards the west, so it's called northwest. In this case, you may want to say west north when you take an angle from west down to north, and usually this angle is 45 degrees because it's directly at the middle. Remember, the angle difference between the north and the west is 90 degrees because they are perpendicular. So this angle here is 45 degrees, and you check that out. For the case of southeast, that means the angle is taken from the south to the east here, and we have 45 degrees. So if a town lies northeast, that means the town lies on the northeast dimension as the case. We'll take some examples and see how it really looks here. Our example here says a town P is 500 meters southwest of Q, and another town R is 200 meters due south of P. Calculate the distance between R and Q. Now let's begin here by showing these lines or these points with our cardinal points. Here I'm going to have Q. Here I have the cardinal point of Q to be this way. This is my cardinal point for Q, so I'll just go indicate the north pole, which is what actually makes this a cardinal point. This is Q. Let me indicate here as Q. A town P is 500 meters southwest of Q, so we're looking at a point on the southwest of Q. Southwest of Q is just about this point, and remember it's 45 degrees from each side. So this is it, and I have another cardinal point here that indicates the points here, Q, P rather. So this is P, and this is the southwest. How do you know it's the southwest? Because it's at angle 45 degrees from either end, either from this end or from this end. It's also 45. So another town arrow is 200 meters due south. So arrow is 200 meters due south, which is going to be about this point down this way. But it's not going to be as long as the other distance here because this other distance is 500 meters. So we have another cardinal point here. This is it. So I'll refer to this point as my arrow, and the distance here is 200 meters. The distance here is 500 meters. So that's what we're looking at, and what they say we should find is the distance between arrow and Q. So we're looking at this very distance between arrow and Q here. Alright, we don't know what this distance is. X, we'll call it X. Now let's see, this is a diagram we have here. First is that this angle between this point and this point here is 45 degree. How is it 45? How do we know it's 45? If you look at this line, this north pole down to the south is parallel to this north pole down to the south. So if here is 45, the alternate angle here will be 45. So this angle is alternate to this. That makes this angle 45 degree. And these two sides are given, and we're asked to look for this other side here. Now let's see which formula are we going to use. This is not a right angle triangle, mind you, because this there's no 90 degree in any of the internal angle here. So from the way it looks, it didn't say that arrow is directly due west of Q. If arrow was due west of Q, then we would have been talking about the right angle triangle. So I'll just indicate with my dumbbell. Let me see how many dumbbell shape can I form here. This angle forms a dumbbell with its side, and I have two extra sides given. That means I'm using a cosine rule. So once you're able to identify what you're using, you just go ahead to solve. Let's see. Here I will have, let me represent them with A, B, C so that you get it. A, B, C. So if I represent this angle here with A, then the side that faces it will be small a. So small a will be X. Small b is 500 meter. Small c is 200 meter. Then capital letter A is 45 degree. Now my formula says A square is equal to B square plus C square minus 2BC cos A. Now if I put it here, I'm going to have A square is equal to, let's see, 500 square plus 200 square minus 2 times 500 times 200 times cos A, which is cos 45 degree. Now that will be equal to 500 square will be 2540 plus 200 square will be 440 minus 2 times 5 is 1000 times 2 is 200,000 times cos 45 degree. That's what we should find here, and that's 7071, and that's 0.7071, sorry, and that will be x square equal to this plus this. Let's punch the calculator here and see what we are getting. 251234 plus 41234, it's equal to 2940. We have 291234 minus 200,000 times 0.7071, 200,123 times 0.7071, which is equal to 141420. So you have 141420. I'll just indicate it here. 141420. Now I'm going to have my x square to be equal to, by the time I subtract this, let's see what we're having. 291234, that's with the 40 minus 141420, that's equal to 148,580. 148,580. Now the square root of that will be 148,580. Square root will be 385.46. So here x becomes square root of 148,580, and that will be equal to 385.46. That's your final answer for x. So this is what x is, so that's the distance here. This other question says a car travels from point X 102 kilometers on a bearing of 72 degree. It then travels on a bearing of 172 degree and stop at a point due east of its starting point. Calculate the distance between the starting and the ending point. This is quite simple but confusing. This is the starting point. This is where the car started from. So you will present that point with the cardinal point. Remember I told you every location will be represented with the cardinal point. So I have this North Pole. This is my starting point. And they said it's moved 102 kilometers on a bearing of 72 degree. Now 72 degree is within the first quadrant here. It has not got into the east, because if it gets to the east it will have been 90. So 72 is just somewhere around here. So which means I'll have the car moving along this direction, which is on the 72 degree, and this is where the car is at the moment. And this part is represented also with the cardinal points. Wherever you have a location, you put a cardinal point here. So we have this angle to be 72 degree, and the distance here is 102 kilometer. Well, let's see. It then travels on a bearing of 172. Now this is where the car is. Now it's going to travel on a bearing of 172, which means it moves down this way up past 90 to this point as if it was going to 180, but it didn't get to 180 eventually. So it stopped there. That's 172. We'll just take a new dimension. This is where the car moves along. But the point here is that the car is on the east of its starting point, so the car should be somewhere around here. Let's see, we'll come to that. This is 172 degree. Okay, now this is the car. They said it's due east of its starting point, so the car is due east of the starting point. This is the starting point here. Due east of the starting point will be along this path. So the car is here. This is the final stop of the car now, and this point is also represented with the cardinal point. So you have this car at this point. Good. And the distance covered here is it then travels on the bearing and then stop. They didn't tell you the distance, so we don't know the distance here, but let's see what we are asked to find. Calculate the distance between the starting and ending point, which means we are looking for this distance here. This is the starting point S, this is the ending point E, and this is the point it break P. We are looking for this distance here. Now what is this angle here? If here is 72, here also will be 72 because they are alternate angles. Now we can quickly see that this very line here is parallel to this line here. So if this angle, because this is the continuation of the line, if this angle from here to here is 72, then from here to here also will be 72. That shows alternate angles. So we have here to be 72 degree, and the whole of this side from here to here will be the leftover. Remember, from the north down to the south is 180, and if you remove 72 from 180, you have just 8 degree left. So you have this small angle here to be 8 degree. So that makes the whole of this angle from here to this point to be the sum of these two angles, which is 80 degree. So you have the total of this angle 80 degree. And we can proceed to do this further. Let's see, what we're actually having is something like that. I can make an extract of what we are having. We're having something of this kind. Okay, we'll see here to be 80. That's the total of this angle. We see here to be 102. We see here to be x, and we're asked to find x. Let's see. We need to know something here. Maybe this angle. We need to know this angle so that we can try and use the sine formula. But let's see if this angle is I want to know what this angle is. Remember, this line here is parallel to this line. If I put through this line out, let's see, if I make this line a straight line, it's going to be parallel to this line here. So if this is the line cutting across these two parallel lines, so I can make out an alternate angle from this angle and this angle. So what this angle is alternate to this other angle. Now I have to know what this angle is. Now look at it. From here to here is 90 as it is. Then from here to here, the whole of this is 172. If I remove 172 from 90, let's see what I'll get. 172 minus 90, that would be 82, and this is 82 degree. So this angle here is 82 degree, which is this. So we have here as 82 degree. But let's say our dumbbell shape will be this. 82 is making a dumbbell with this side, and this one is making a dumbbell with this side. So we can actually use the sine formula, and I could just name them arbitrarily. I could name this A, B, and C. Don't worry about the naming, the one we had here, and that'll help me out. I'll get something very simple. My small a is what I'm looking for, x. My big A is 80 degree. My small c is 102, and my big C is 82 degree. Now my formula says A over sine A is equal to C over sine C, and that's like saying x over sine 80 degree is equal to 102 over sine 82 degree. Now cross multiply here just to make x my subject of the formula. X now becomes 102 times sine 80 degree divided by sine 82 degree. Now let me see what that will be. The value of x now will be 102 times, what is sine 80? 80 sine 0.9848. So we have 0.9848 divided by sine 82 would be 82 sine 0.9902 or 0.9903 approximately. So we have 0.9903. Let's see the final value of x. If I punch this out, you have 102 times 0.9848, which is equal to this, divide by 0.9903, and that's equal to 101.433. So we have 101.43 approximately kilometer. So this is the value of x, and that is what they say you should look for in this question. Now we'll go over to another question. This time around, the question says a man travels from town X on a bearing of 60 degrees to town Y, which is 200 kilometers away. At town Y, he changes course and goes to town Z on a bearing of 195 degrees. If Z is directly east of X, calculate a three significant figure how far Y is from Z. Let's see. The first thing here is this. The man travels from town X on a bearing of 60 degrees. So this is town X. We'll present it with the cardinal points, and we'll just do this quickly. This is the north, and this is town X. So I could use a different highlighter for that. Now the man moves on a bearing of 60 degrees, which means he comes this way from the north 0 down to 60 degrees, somewhere around here. And that's 60 degrees, so he travels along this path. And he gets to a point here. It makes a cardinal point also. This is the point where the man is now. And this is point Y, which is 200 kilometers away. So here you have 200 kilometers. Sorry, I'll just take that again. You have 200 kilometers, 200 kilometers. Now he changes course and goes to town Z on a bearing of 195 degrees. So he moves down this way on a bearing of 195. So from this point Y, he goes 195 should be somewhere around here. It's past 180. So this is the man coming down this way now, directly east of X. So it's coming down here to stop somewhere around here. And they said this point that he stopped is directly east of X. So we have this point here going to meet where this man is now. So this is the point the man is. He's making another cardinal point here. This is the man here. And what did they call this point? They call it town Z. So here is town Z. This is X, Y, Z. This whole angle here is 195 degrees. That's from the North Pole down this way. And well, let's see how far Y is from Z. So we're looking at this distance, and how far Z is. What's the distance between Z from X? First and foremost, we want to find this distance here. We'll find this distance. Okay, so we can just represent it with something, maybe S. We'll find this distance here, and also find this distance here. First and foremost, I want to extract our triangle. Let's see how it really looks like. This is the triangle I'm having. Remember, this is not a right angle triangle. We have X, we have y, we have z. Let me take this very well. X, y, z. This angle here will be 30 degree. Why 30? Because if from here to here is 60, the remaining one here will be 30 to make it 90. Remember, this is a line that is going on the east dimension. And let's see, what else are we going to look for? This other angle, let's see, we can get this. Now this line here is parallel, this very line here, if I take it, is parallel to this line. So which means whatever this angle is will be alternate to this angle. Now if I can get this angle, I'll plus it with 90 degrees, so I'll get a total of this angle. So what is this angle going to give me? From here to here is 195, and from here to this point, this line here, is 180. So if you remove 180 from 195, you get the remaining fraction of the angle, which means 195 minus 180 would be equal to 15 degree. So we have this fraction here to be 15 degree. Why? Because this is 15 degree. I just hope you understand what we're doing here. So we have the total of this angle here, 15 plus 90, which is 105 degree. And this side is giving us 200 kilometer. While this other side is what we are looking for, S. Well, we can see the dumbbell shape here. This is forming a dumbbell shape with this side, and this angle is forming a dumbbell shape with this one here. So we have two dumbbell shape, which means we are looking at sine. So we'll just quickly identify them. Let's say we take them arbitrarily as ABC, so that we'll really get what we're doing. Let's say A, B, and C. So we're looking for B and C. Small b is what we are looking for, and that's what we design by the letter S. Big B is 30 degree. Small c is 200 kilometer. Big C is 105 degree. Now let us see. The formula says B over sine big B is equal to C over sine big C. And if I'm looking for this small b here, I'll have to cross multiply, so that I'll have B times sine big C is equal to small c times sine big B. Now if I divide here by sine C and here also by sine C, this will cancel out this, so I'll have my B to be equal to C times sine big B all over sine big C, and that will be equal to, my C value here is 200 times sine B, which is sine 30 degree, all divided by sine C, which is sine 105 degree. Let's see, I need some more space. Where can I take off now? Let me see if I can compress this here a little. So I have 200 times, what is sine 30? 0.5, all divided by sine 105. Let's see what that will give us. 105 sine 0.9659. So we have 0.9659, and this will give us a final answer, which says B is equal to, let's see this, 200 times 0.5 divided by 0.9659, and that's equal to 103.53. So we have B is equal to 103.53. But the question here says approximate to 3 significant figures, which means I may want to show here that B is equal to 103. Then the rest turns into 0. 104. Sorry, there's we take our boundary here. So we are having this as 104 if we are approximating to 3 significant figures. This is what we do. I believe you know what it means to approximate. You take a boundary actually across these points, across here, and you approximate this to these points. It becomes 1 and is added to that, and so you have 104 kilometer. So this is your final answer for the first phase. Now the second phase says the distance of Z from X. Z from X. We're looking at this other distance here now. Let's see, we can just take this whole thing out quickly. Or I think you can just solve that yourself. Try and solve this other question yourself, the distance of X from Z. So we're looking at how to solve this distance. You can try it out and see what you're going to get. Remember the value for these parts that you got and try it out. This question says a sailor traveled 150 kilometers on a bearing of 35 degrees from P to Q. He then changes his course and travels on a bearing of 200 degrees to R, which is 45 kilometers away from P. Well, find correct to 2 significant figures, the distance between R and P and the bearing of R from P. Let's see how this one works. This is the points here. We'll call this point P, which is the starting point. This is where he began his journey from. And they say he travels on a bearing of 35 degrees, which is somewhere around here. So he goes along this direction. This is where he is at the moment, and this is point Q. So we have this to be 35 degrees, and the distance covered is 150 kilometers. Now he changes his course here and travels on a bearing of 200 degrees, which is this bearing here. So he's coming down this way and he gets to a point here. This point he calls arrow. This is point P and this is point Q according to the question. And they said arrow is 40 kilometers away, and this bearing is 200 degrees. Arrow is 40 kilometers away from P, so we can see here that the distance between P and arrow, sorry, that didn't go too well, we'll just manage it that way. 40 kilometers, and it said find the distance between arrow and P. Arrow and P. That's crazy. Arrow, which is 40 kilometers from P. Find the distance between arrow and P. The bearing of, wow, this is a very crazy question. And the question seems very funny here. We already told the distance between arrow and P, so why are we calculating the distance between arrow and P again? Except the question is actually wrong somewhere. Probably they said that is 40 kilometer away from Q. But all the same, let's look at the second one here. The bearing of arrow from P. Bearing of arrow from P, which is this bearing from here down to this point. So we need to know this angle, so that will add it to 35. And that becomes the entire angle. But we can only find this angle if we know this distance here. Okay, that distance is actually talking about the bearing, the distance between arrow and Q. So we'll look at arrow and Q, not arrow and P. So we're looking at this distance in the first place. Is it possible to find this distance? Yes, it's possible, but we need to know this angle. Well, that's not the question. We'll leave this question out. It's all confusing. Three poles are located in such a way that the bearing of pole B from pole A is this. Now let's see. We're going to do some sketch here. This is pole A. It's represented with the cardinal points because it talks about a location. And the bearing of B from A is 67. Actually, 67 degrees is somewhere around this point here. So we have B on this bearing. Stop here. And we have this point to be B. So here we identify here as A and here as B. And this bearing is 67 degree. They talk about the distance, and distance between them is 59 kilometer. So we have 59 km. Let's see what else is given. The bearing of pole C from A. Now we're going to look at pole C from A. They said is 312, which means this C would be somewhere around here down to 270 back to this point, which is 312. So you have C on this point, and they said it's 70 kilometer apart, so this line should be a little longer than this other one. This is point C, and the whole of this bearing is 312 degree. That's from the north down to where you have your C dimension. Alright, let's see. Find the distance between B and C. What do I ask to find is this distance between B and C. Ooh, I'm supposed to take a straight line, but it's okay. And hence the bearing of C from B. We'll look at that later, but let's check out this one. If the distance between here is 70 kilometer, distance between here and here is 59 kilometer, which is what we have inside there. So I can take it off and write it outside. So this distance is actually 59 kilometer. What we're looking for is this distance here, C and B. Now we're going to look at the dumbbell shape that is formed here. This angle forms a dumbbell shape with this side. Remember, it is the angular side that forms a dumbbell shape. And you have two extra sides left, which talks about the cosine rule. So this angle is what we should know, the whole of this, and the whole of this can be gotten. The remaining part of this will be 312 away from 360, because if it had gone round it would have been 360, and here you have 67, So let's see what this other fractional angle will yield. That would be 360 minus 312, 48. So we have this small angle here to be 48 degree. And that makes the entire of this whole angle from here to here 48 plus 67, 115. So we have 115 degree. Now that's we can name the arbitrarily. Okay, ABC is already named ABC. So we're looking for the small side A. Represented by X. B is given as 70. C is given as 59, and capital letter A is given as 112 degree. Sorry, 115 degree. We have this as 115 degree. Now if I'm using my cosine rule, it says A square is equal to B square plus C square minus 2BC cos A. So that becomes X square is equal to 70 square plus 59 square minus 2 times 70 times 59 times cos 115. Let's see, this will be 70 square will be 70 times 70, which is equal to 4900. So we have x square to be equal to 4900 plus 59 square times 59, which is equal to 3481. 3481 minus 2 times, let's just multiply this whole out, 2 times 70 times 59, which is equal to 8260. So we have 8260. I'll take this off. (8260) times, let's see what cos 15 will lead. 115 cosine minus 0.4226. So we have minus 0.4226. So here we're going to have a square to be equal to, let's see, we have 4900 plus 3481. Now minus this times minus this will give us plus, let's check it out, 8260 times 0.4226, 3490.676, 3490.676. Let's see. Now I'm having my a squared to be equal to all this whole thing add together plus 3481 plus 4900, which is equal to 11871 1.871.676. Then my x, or rather a and x are the same thing, will be equal to the square root of 11871.676, and that will be equal to 108. 108. They said, so how many significant figure here? Okay, it didn't specify. 0.95. So this is what you're getting for a value of a or x, whichever one. Now we'll just move over to the next question. It says, and hence find the bearing of C from B. Looking at C from B will be this bearing from the whole of from here down to this point. Now all you need to do is to get the angle between this and this. Remember, here is 67, here also will be 67, because you have parallel lines, so you have 67 here. Let me take this, here will be 67. If we can get this angle, we'll add it to 67 and add it to 180. Let's try it out. Let's see what this will yield. Okay, to lead me drawing another angle. Let me see, 108.95. That's what we got there. Okay, we had this cardinal point. Up to this point forms another cardinal point, and we have another one going to this point, although this one seems longer. It forms another angle with C here, and the whole of this was taken as 67 degree. The whole of this from here down to this point was taken as 312 degree. And we're able to solve for this location here. We solve for here and we got let's see what we got. 108.95. Here we got 108.95, and the whole of this angle from here to here was giving us let me see, 360 minus 312, which is equal to 48. The whole of this angle was plus 67, 115 degree, and this place was giving us 70 kilometer according to the question, and this was giving us 59 kilometer. Now we're looking for this bearing from here down to the north. So this is what we're looking for now, the bearing of C. This is C, B, and A. I'm looking at bearing of C from B. Now what we said is if we could get this angle already is the same with this 67 because it's alternate angle. Remember, this line is parallel to this line, so we have alternate angle here as 67 degree, and the whole of this from here to here is 180. So from here, this point down to the north will be 67 plus 180, and that is equal to 67 plus 180, 247. You have 247 degree. That's the whole of that angle. But this very angle, if you add this one to it, to give you the bearing. Now what we need to find is this angle. And here we say we can take this dumbbell shape. We can take this dumbbell shape, the whole of this dumbbell with the side, and the whole of this dumbbell with the side. So we're looking at sine rho, and we can just quickly do this. Small b is given as 70 kilometer. Big B is given as what we are looking for. Small a is 108.95, and big A is 115 degree. And let's see, let me change this highlighter. A over sine A is equal to B over sine B, and that's like saying 108.95 over sine 115 degree is equal to small b, which is 70 over sine b. We don't know, so we'll just leave it as sine b. Now cross multiply to make sine b the subject of the formula. Then we'll have sine b times 108.95 is equal to 70 times sine 115 degree. I have my sine b to be equal to 70 times sine 115 all divided by 108.95. Let's see, sine b will be equal to, let's punch that out, 70 times what's sine 115 sine 9063 0.90. Let me scroll this out. 63 all divided by 108.95. Then I'll have sine b to be equal to, if I punch my calculator out there, 90 times 0.9063 divide by 108.95. You have 0.5823. Then b will be sine, will be equal to sine inverse 0.5823. Let's just see what that will be. Here we have this times 70 divided by 108 2.95, just for us to be sure, which is equal to this. That's the same thing we're having here. Then second function sine, which is 35.6 degree. So we have b to be equal to 35.6 degree. That's what you're having there. So this angle here is 35.6 degree. Now you add up this angle with the remaining of what you already have here, which is 247. So you have 35.6 plus 247, and that will be equal to 282.6. So we have 282.6 degree. This is what you're having as your final answer. So that is the bearing of C from B.